Hi class, in lesson 15.4 you will be using histograms. Learning targets for today, you will organize data into a histogram and analyze data presented in a histogram. Key terms to look for in the lesson today: histogram and frequency table. Please turn to page 1038, problem 1, Onward and Upward. Minneapolis and St. Paul are known as the Twin Cities because they are close to each other in Minnesota. Both cities are home to flourishing downtowns with tall buildings. For number 1, look at the graph shown. Please answer letter A with your group members. For letter A, this graph is different from a bar graph because the bars are touching each other. Also, there is no name under each bar on the horizontal axis. There are only numbers marked as intervals. The graph shown is a histogram. A histogram is a graphical way to display quantitative or numerical data using vertical bars. The width of a bar in a histogram represents an interval of data and is often referred to as a bin. The height of the bar indicates the frequency, or the number of data values included in any given bin. Bins are represented by intervals of data instead of showing individual data values. Please answer letter B and letter C with your group members. For letter B, the information that the histogram displays is the number of floors in the tallest buildings in the Twin Cities. Letter C, the data are discrete. You can only have whole number floors and buildings. Please turn to page 1039. Answer number 2, letters A through C with your group members. For number 2, letter A, there are 5 bins that are shown in the histogram. Letter B, each bin represents a different range of 10 floors, and all the bins are the same size. And for letter C, the height represents the number of buildings that correspond to the different intervals or bins of the number of floors. The first vertical bar on the histogram represents 8 buildings that have at least 10 floors but less than 20 floors. Please answer number 3 with your group members. For number 3, the second bin has at least 20 floors but less than 30 floors. The third bin, at least 30 floors but less than 40 floors. The fourth bin, at least 40 floors but less than 50 floors. And the fifth bin, at least 50 floors but less than 60 floors. Please turn to page 1040 and answer number 5 with your group members. For number 5, Bella is incorrect. In order to determine the number of buildings represented, Bella must determine the height of each bar, which indicates the frequency for that interval. Then she must add the frequencies together to calculate the total number of buildings. When you add those numbers together, there are 60 buildings that are represented in the histogram. Please answer number 6, 7, and 8 with your group members. For number 6, no, you cannot tell if any buildings have 31 floors. You can only tell how many buildings have between 30 and 39 floors. Histograms do not supply the individual number of floors per building. For number 7, it is not possible to determine the number of buildings that have more than 35 floors. The interval between 30 and 40 represents the number of buildings that have at least 30 floors but less than 40 floors. There is no way to determine exactly what values occur in this interval. For number 8, remembering that the range is the difference between the highest and the lowest data value, it is not possible to determine the range of the data set. The histogram does not give exact values, only intervals. so there is no way to determine the highest and lowest data value in order to calculate the range. Please turn to page 1041. To create a histogram, data is usually organized into a frequency table. A frequency table is a table used to organize data according to how many times a data value occurs. The frequency table for the number of floors in the Twin Cities' 60 tallest buildings is shown. Please refer back to page 1038 and compare the histogram to the frequency table above. Answer number 9 with your group members. For number 9, the intervals along the bottom axis on the histogram are the same intervals in the first column of the frequency table. The frequencies listed in the frequency table are easy to read since the numbers are written, whereas on the histogram, I must to read the frequency based on the height of the bars. Let's move on to problem 2, building up, not spreading out. Did you know that New York City has over 5,800 tall buildings and is home to the Empire State Building, which is 381 meters tall? In fact, it is the third tallest building in the U.S. Not to be outdone, Chicago is home to the Willis Tower, also known as the Sears Tower, which is the tallest building in the U.S. It stands an impressive 442 meters tall. So how do these big cities stack up to each other? Are there any similarities or differences in the number of floors each city's 20 tallest buildings have? Look at the table listing each city's 20 tallest buildings on the next page. Please turn to page 1043. To organize the data, you will make 2 frequency tables. You will then make 2 histograms to compare the different number of floors for each city's 20 tallest buildings. Please answer number 2, letters A and B with your group members. For number 2, letter A, the least number of floors in the table of New York's 20 tallest buildings is 54. For letter B, these intervals are appropriate. The least value is 54, and the greatest value is 102. Her intervals do span this range. Please answer letter C with your group members. If a data value lies on one of the bounds of the histogram, it should go in the bin to the right of that bound. For letter C, the name for your frequency table should be the number of floors in New York's 20 tallest buildings. On the left, we have the number of floors with the ranges 50 to 60, 60 to 70, 70 to 80, and so on. And on the right column, we have the number of those floors in the building listed under frequency: 10, 4, 5, 0, 0, and 1. Please turn to page 1044. Number 3, now that you have created a frequency table, let's create a histogram. Please answer letter A and letter B with your group members. For letter A, you will name your histogram the number of floors in New York's 20 tallest buildings. For letter B, completing the histogram, we have our title or our name up at the top. We have our number of floors indicating the horizontal axis, and we have the number of buildings indicated on our vertical axis. Please answer letter C and letter D with your group members. For letter C, the distribution is skewed right because there is a peak at the 50 to 60 interval on the left side of the histogram with fewer data points on the right. There is also a gap from 80 to 100, which means many of the 20 tallest buildings in New York have 50 to 60 floors, and only one building has 100 or more floors. For letter D, we are going to disagree with Andrew. Andrew has mixed up what each axis represents. There are 4 buildings that have 60 to 70 floors. This will conclude lesson 15.4 on using histograms. Please let me know if you have any questions. Thanks.